This subVI called Listen for Audio will actively monitor a signal or an audio signal, and anytime that you detect that the signal level has exceeded some threshold, then it exits. But until that time, it's going to wait. So we'll make good full use of the sound input read built-in subVI. We need a couple controls from this one. One is the number of samples per channel, and then also the task ID. Now this subVI is not really intended to stand by itself, but rather to be used in another subVI called grab audio. So for that reason, we'll assume that the task ID has already been established by another subVI. We would like to keep track of whether or not any errors are being generated by this subVI, so we need to propagate the error cluster as well. Timeout we don't need to worry about. That's where we actually pick up our data, our audio signal. So let's wrap this in a while loop. Again, the general theory here is that we continuously grab a short block of audio and then check that audio to see whether or not it's exceeded some predefined threshold. When it does so, then we need to be able to exit or break out of the while loop. Also, whatever was the most recent audio that was captured, we also want to generate that as an output. So that way, when we detect that the audio has suddenly changed in a significant way, we don't actually lose that value. We make that available. It's important to make sure that that's also a loop tunnel, because we're only trying to keep the most recent version, not all of the previous versions. So somehow we need to get the results of that sound input read to generate the stop condition for that loop. So we need a couple of helps here from the Waveform palette. Here we have a subVI that can calculate the max and min values of the waveform. Let's see if we can figure out why that's a broken wire. Alright, as it turns out, sound input read is actually producing an array, but waveform min max only wants a single waveform. Now, very similar to the index array, we have the index waveform array. As I said, it's very, very similar to index array, which you're probably more comfortable with. So here we see that picks off a single element from that array of waveforms. The index defaults to 0. Turns out that 0 corresponds to the left channel of audio, of your stereo audio. And you could just do a copy on that one, set that to 1, and that would be the right channel. It's probably best to make this be able to operate so that it can detect significant audio level on either the left channel or the right channel. But I'll let you work on getting the stereo part established. So the general idea here is we look for the maximum value within that waveform and compare that against a threshold. If we say the max value exceeds that threshold, then we're supposed to break out of the loop and then end the subVI. So we have a default value of 0.1 for that threshold. Incidentally, the proper default that we were looking for was 1024, fairly short number of samples. And that's how we establish those as the default values. Alright, so if we were only monitoring that one channel, you'd just be able to connect that right up to the loop control at the lower right there. The thing looks like a stop sign. To deal with both channels, you can OR together those Boolean results from the comparison. So you'll need to make use of that one. Also, I'd like to point out that since this loop runs continuously in a very fast sort of way, to ensure that we get decent operating performance with the rest of the operating system, put the wait until next millisecond multiple, even if you only give it its default value of 0, that frees up the thread of this subVI back to the operating system on each pass. As I said, it's more of a performance related thing. Finally, I'll create an error cluster just associated with the sound device, and I'll leave you to continue getting this one wrapped up.